Hi folks, it's Mr. DeFaulty again. Welcome to another session of my video notes. Today I will be talking about domain and range from a graph. We will look at 4 different graphs, and the first one here comes from a scenario from Springboard about Tom hiking along a circular trail known as the Juniper Loop. The graph shows his distance d, right there, from the starting point after t minutes. So it's important to note, first of all, what the domain and range are from these things, because they each have meaning according to the situation. So the first thing I want to talk about, I'm gonna change my color here and make sure it's big enough so that we can see it. The domain is always about our inputs, our x's, about our dependent variables. In this case, in this graph, we don't have an x to look at. We have instead a letter t. Now t normally would be the x that we are used to seeing, but because we are dealing with a situation regarding Tom hiking, it wouldn't make sense to use x, but it makes sense to use a letter t since that stands for time, as you can see over here. Whereas on this side we have d, and d represents our distance. So you can see the two things are definitely related to each other. D for distance. So getting rid of this stuff here. Our t, our time, represents our domain. Whereas our range is about the distance from the time the hike actually began. And you can see that it goes up, it goes to the side, gets flat around here, and then it goes up again, stays steady, and then it goes down again. Everything on this graph means something about Tom engaging in his hike. And but I want to focus just on the domain and range for now. So domain, the domain covers the time in minutes, and it's independent because time runs on whether we want it to or not. Regardless of whether Tom goes on his hike, the time will continue going on. The clock will keep ticking away. So we want to represent our domain from the time that he began his hike, in this case, which is at 0 minutes. And it starts at 0 minutes, but it continues from there all the way over to where he stops, which is at 150 minutes. There are 2 ways to show domain and range. One is called set notation, which involves parentheses and brackets, and the other is using inequalities. And I want to show both styles to you so that you can have exposure and then decide which one is better for you. But it's good to know how to do both, just in case. So for set notation, which is this one here, set notation. Set notation involves using parentheses and brackets, like I said. In this case, because he clearly starts at a certain time, which is 0 minutes, we use brackets because that indicates a clear starting point or a clear stopping point. And because he ends his hike after 150 minutes, we put brackets on that as well. Again, the brackets indicate a clear start and a clear stop. Now, I could represent this using a different method called inequalities. So I'm going to put or, and then go ahead and switch to that. So using inequalities, I still have my beginning and my end, which is 0 and 150. I'll put a little more space between them for reasons that you will see in just a moment. Now, over here I put minutes below the numbers, but here I don't need to do that because instead of putting them below the numbers, I will put what these numbers represent at the center. Now, I said earlier that 0 and 150 represent the time in minutes, so I will put time in minutes. Okay? That's our theme for these numbers. And to show that the time in minutes is between 0 and 150 minutes, we will use an inequality, and it's less than or equal to, because that always indicates, in this case, when it's set up this way as a compound inequality, it shows between. And the equal part indicates that this here on the graph, if you take a look over here, this is a clear starting point, and this is a clear ending point. And because it's a clear start and finish, we use the equal part of our inequality. If there was any gap at the beginning or end, then these would not have the equal components as you see here. And that's a domain. Now we can switch over to range and do the same thing. Now the range covers the distance that Tom hiked from the time that he started. And as you can see, he went quite a distance. Now this is measured in kilometers, as you can see over here along the y-axis. And he started at 0 kilometers because at 0 kilometers he hadn't yet even taken one step. But then he started to walk, and he walked and walked and walked, and a couple hours passed by, and he finally decided at 7 kilometers, I think I'm done. I'm going to head back. So 0 kilometers gets a bracket because that's a clear starting point, and 7 kilometers gets another bracket because that's a clear ending point. That's where he's decided, enough is enough. I am tired and ready to go home. So that gets a bracket also. And that also is set notation. So set notation again. Okay, but we can also represent this using inequalities, specifically a compound inequality. So I can do that in the same way I did my domain. So I will set up my same numbers, 0 and 7. But in the middle, I need to create an explanation of what these numbers are about. So 0 and 7 have to do with the distance from beginning to end. So I'm going to put distance from start. Okay, that goes there. And again, less than or equal to, less than or equal to. And I'm going to move this aside just a little so it's a bit more clear and not so cluttered. So less than or equal to 7. That's a lot better. So this means that Tom hiked from 0 kilometers to 7 kilometers. He went 7 kilometers on his hike, and it took him a total of 150 minutes to do that, which is over 2 hours long. That's 2.5 hours long. And that's how you write domain and range using both set notation and inequalities. So I'll indicate that over here as a compound inequality. And once again over here, compound inequality. Okay? So moving on to our second example. Here, in the homework assignment tonight, one of the things you have to do is you have to indicate whether or not your graph represents a function. And I want to begin this one with that discussion. So to see if a graph is a function, all you need to do is perform what's called a vertical line test, which means you draw a series of vertical lines through the graph. And what you're trying to figure out is how many times does each one puncture the graph. So if you look closely here, there's one hit right there. I'm going to switch to another color. One hit right there, one hit right there. Okay, and that means that for this first red line, I hit the graph twice. Now, automatically, that means this is not a function, because if you look closely, what that would indicate is that for these 2 points here, this one and this one, you have one input trying to pair with 2 different outputs. And that is just not going to work. It's not going to work. So as we know from the meaning of a function is a one-to-one relationship. One input creates one specific output that only fits that one input. And in this case, we clearly have a violation of that rule. And it happens many times. It happens here and here. It happens here, and it happens there again. Now, we don't need to mark all the times that it happens. The moment it happens with one of your vertical lines, no matter where it is on the graph, that graph ceases to be a function, at that location or in its entirety. So first I want to say this graph failed the vertical line test and is therefore not a function. Okay, first important thing to note. Now from here, we can go on to talking about our domain and range. I'm going to switch to a thinner marker here so we don't run out of space. And I'll get rid of these marks so it's not in the way. Perfect. Okay, so let's cover domain first. Now the domain, again, is your input, all your x's, right? Your independence. And that, in this case, goes from the far left all the way to the far right. Now, on this particular graph, it's a little hard to see exactly where that far left and far right are because they go a little beyond -2 and +2. So we're going to do a slight estimate here, okay? We're going to say for the domain, oops, wrong. That was not the right mark. Bracket, because everything on the circle is a closed dot, and it goes from the left to the right, so it's going to be from about -2, we can say -2 let's say -2.2, right? And it stops at +2.2. Again, as an inequality, this would look like this. So it would be -2.2, +2.2, less than or equal to, less than or equal to. And in this case, because we don't have a story regarding this circle, we don't have a label other than the x itself. So this would be simply x. All the x's are between -2.2 to +2.2. And then the range for this is about the height, how tall this circle is. And if you look closely, oops, the range goes from all the way down here to all the way up there. And that whole height from here all the way to there, that's from -2.2 all the way to +2.2, but along the y-axis, as you can see right there, along the y. So our domain, our range, excuse me, has to be about the height of this thing. So this is from -2.2 to +2.2. Again, everything is closed because there are no breaks in the circle. But this time, because we're dealing with the y's, the outputs, the dependents, we put the letter y in there. Okay? And as an inequality, it would look like this. Oops, that's wrong. Switch to orange. Thank you. So as an inequality, it would look like this. It would be -2.2, +2.2, less than or equal to, less than or equal to, y. And I just realized I made a mistake over here. I apologize for that. I should not have put this inside the set notation. I'm very sorry about that. What it should have been is comma 2.2 and then bracket. Okay, there we go. That's better.